So let's go through step by step the fundamental ideas of writing a simple program. When we create a program, we want to plan our work before we start typing. We don't want to just hack something together, start typing and make edits and try to blunder our way into a correct program. We want to think carefully about it. So to help us with that, we're going to think about an approach that George Polya, a mathematician who worked mostly during the middle part of the 20th century, introduced 4 steps of problem solving that are extremely useful in all forms of problem solving. The steps are common sense, but we tend to not think carefully about the steps, and we tend to go out of order when we are solving problems if we haven't practiced this process. So the first step is we have to understand the problem. And understanding the problem means a lot more than just being able to read a question or see something going on. We really have to think deeply about it. So we'll talk a little bit more about these steps as we go forward. But once we fully understand a problem, then we want to figure out what to do. We don't want to jump into doing that thing yet. We want to think about a bunch of different possibilities, pros and cons of different approaches, different methods to tackle the problem. And when we devise a plan, we actually are devising multiple plans and then compare and contrast and then choose the best of all possible plans. And then at that point, we can execute the plan. So we know exactly what the problem is. We have our plan. We are convinced that it's the best approach. And then we execute that plan as precisely as we can according to our plan. Then once we've executed the plan, then we want to look back, check our work, check at each step, make sure that the execution was correct, make sure that it was an appropriate plan, that we devised a good plan for the problem, make sure that we actually understood the problem at hand. Then we can look around and see where else we can apply either the same technique or other places, maybe new scenarios that the same problem or the same solution could be applied. Now, as we're going through, we don't always go directly in a linear process. Sometimes we work and we think we've understood the problem, and so we move on to devising a plan. And in the middle of devising a plan, we realize that we didn't really understand all the pieces, so we go back to the problem and we look at it some more. Sometimes we're in the middle of execution and we realize that our plan wasn't devised appropriately. We have to go back. Maybe we didn't understand the problem all the way. So it's back and forth. But what happens as people, we tend to jump straight to step 3 when we're dealing with a scenario. And that will definitely cause problems for us when we are working with writing programs in particular, but in a lot of problem solving in general. If we jump straight to trying to do something, we will often overlook details, or we will just have a bad plan in mind. So all the steps are important, they're all vital, and it's really important that we go kind of step by step, especially as we're learning the process. If it's something that's not really a problem for us, if it's something that we already know how to do, and when you take a quick look at it, we know what's going on, we know what the appropriate plan is, and we execute that plan. But if something is actually a problem or we don't know how to solve it, it's really, really beneficial to think in these steps. So with the pizza problem that we're going to look at, we need to understand our problem. And so when we understand the problem, sometimes there is a considerable amount of work to do before we can begin the planning process. And when we think about understanding the problem, we have to think about what do we know, what do we not know, what's important, what's not important, and there's a lot of other questions that we'll ask at this point as well. So in understanding whatever the problem happens to be, we need to look into every possible facet of what is going on, what is important there. So in this particular scenario, our description of our problem is we want to just write a program that outputs the results of a pizza order. So we're given a list of available toppings and a list of requested toppings. And if the topping is available that has been requested, we're going to output a statement that the topping is being added to the pizza. And if that topping is not available, then we're going to output a different statement that says that the topping is not available. Then at the end of it, we're going to output a statement that the pizza with all of the available requested toppings is ready. So not much to understand in the English description of this. The detail is going to be in devising our plan and executing our plan. In terms of writing code, the devising the plan is coming up with pseudocode, an outline of what's going on. The execution is actually writing the code. So the execution will happen considerably later in the process. In our particular task, we want to use the Oxford comma, partially because I like the Oxford comma, but also because we have to think about it slightly differently if we are using the comma versus if we're not using the Oxford comma. So to devise our plan, we want to begin writing out a pseudocode for our particular task. The nice thing about Python is that pseudocode and Python often look very similar to each other. There are some aspects that will be different, but some people have jokingly said in the past that Python is executable pseudocode, that we are going to write out the steps that we want to do without necessarily worrying about the actual Python syntax. But at the end of it, it's very similar in many situations. So we need to get a list of available toppings. So that's our first step. The next step is we need to get a list of requested toppings. We said these are the two things that we are kind of given at the beginning. And now if we're going to create a pizza, or at least a virtual pizza, we can benefit from creating an empty list that represents the pizza that we are making. And then for each topping that's in the list of requested toppings, we're going to check, is that topping available? If so, then we're going to add it into the list that represents the pizza that we're making. And otherwise, we'll output a statement that says the topping is not available. After we have completely assembled our pizza, then we're going to output a statement that the pizza with those appropriate toppings is ready. It turns out that the last statement is actually the one that is the longest. It takes the most work to kind of sort out and think about the appropriate way to output that statement. But we will start at the beginning of these few steps of pseudocode, get our list of available toppings, get our list of requested toppings, create that empty list that represents the pizza we're making, and then the loop where we're constructing the pizza. And then we'll go on to the output at the end of dealing with how to actually say this particular pizza is ready. All right, so we have our outline of the problem. We've devised a plan, at least for the first part. So now we're going to turn that into code. So we need to get our list of available toppings. So we will just hard code a list of available toppings. We can make up whichever toppings we want to have available on our end. So the available toppings that I have in this particular example, it's a space situation here with the black olives. That you would have room to type that all on one line. This just happens to be one of my favorite pizzas, and so these are going to be the available toppings that we have. And then for requested toppings, that's going to be saved in a different list, and we can put whatever we want into that. There should be some overlap in your testing, but not necessarily. So there's some overlap that I have included here, and then I added a couple of things that are not on that available toppings list, so we can see what happens in those cases. All right, then we're going to create an empty list for the pizza we're making. We can call that empty list whatever we want. I chose to just call it pizza. And so pizza is an empty list, and we're going to add toppings to it as we go forward. And so then our next step is we want to loop through the requested toppings and add the toppings as appropriate, or give the appropriate statement that that topping is not available. All right, so what will that look like in code? We start off available toppings using the Python naming standard. We use the snake casing here, so available underscore toppings, and we put all of those toppings in the list. And then we have our requested toppings list, and we have our empty list for the pizza. Okay, so now what we're going to do is we're going to look at each individual topping in the requested toppings list, and one by one we're going to analyze it to see, is it available? And if so, we're going to add it to the pizza, and if it's not available, we'll output a message that says that topping is not available. So for each topping, as we look at it, we want to check to see, is that topping in the available toppings list? And in Python, we can check that by saying if topping in available toppings. That's going to be a Boolean value. It will either be true or false. Topping will either be there or it won't be. And in the case of this particular example, mushrooms is the first one being looked at. That's the first topping being looked at, and mushrooms, the word is in available toppings, so it will be true at that point. And so what will we do? We will print out a statement that says we're adding that topping to your pizza. We're using a formatted string here so that we can put that value directly in place. All of the spacing and so on is part of the formatting. So we'll add that topping to the pizza, but we don't want to just say we're adding it to the pizza. We want to actually do that, and we will do that by appending that topping to the pizza list. So as we're working through the toppings, any topping that is available, we'll say we're adding it, and then we append it to the list. On the other hand, if the topping is not available, so if topping in available toppings is a false value, if it comes back as false, then we want to print out something that says that that topping is not available, or if that's a plural term, we want to say that that thing are not available. So if we say green peppers are not available, extra cheese is not available in those kinds of settings. And so to do this, we have topping is the first word now in the sentence. We want to capitalize that. So I used the dot capitalize method here for strings to capitalize the first letter of the first word. And then we want the verb to show up as either is or are. Now, this isn't a perfect test that we're doing here, and it's not overly important in our example. But just to give you the idea of what's going on, most of the time when we look at the toppings, we'll have maybe, at least in the available toppings that we have here, most of these are plural most of the time. Well, I don't know if most of the time, lots of the time, the topping is a plural term. So I'm going to set the default for verb to be are. But sometimes it's a word that's not plural. So extra cheese, for example, we don't want to say extra cheese are not available. We want to say extra cheese is not available. And so we could add in a line that says if the last character, so that's what the bracket -1 here, the index -1, it says if the last character is not an S, then let's make the verb be is. And for our examples, this will work correctly. On this particular case, the plural things have the S and things that are not plural do not. If we've had a topping like, for example, I don't know, asparagus, we would want to say asparagus is not available. This code would say asparagus are not available. So if we were really worrying about getting the English right, we would have to add a bunch of extra tests and be more precise with the rules on what makes something plural, what makes something singular. But this kind of gives us an idea that we can modify things and make them appropriate, or at least mostly appropriate, based on the context, um, based on some information that's inherent or built into the word. Again, there are some things that are plural that do not end in S. There are some things that end in S that are not plural. And so this will not be correct all the time, but it will be correct a large portion of the time. Okay, so we have at this point now, we've built the pizza. We've gone through the steps of building the pizza. You've looked at every single requested topping, checked to see is it available, yes or no. If it is available, we've added it into the list. We've appended it to the list. If it's not available, we have said that topping is not available. So now our output is going to depend on some things about what we've added to the pizza. So our print statement at the end that we want to look at is going to be something like your, and then there's a space, pizza, and then there's another space, some more text that might be there, is ready. And in our description, we want, if it's a plain pizza, we want to say your plain cheese pizza is ready. If it's not a plain cheese pizza, we want to say your pizza with, and then whatever the toppings that we've added, we want that to show up in here, is ready. And so what I've done is put in a variable that we're calling plain and a variable that we are calling prep. And these two variables are going to be filled in as appropriate based on what we've added to the pizza. Okay, so let's build the code before that gets us to this point. Okay, so what's going to matter, what's going to make the deciding factor in what goes into these two pieces is going to be how long the pizza list is. So let's store that value off. We're going to need it a couple of times. And so we will just say, how many things have we added to the pizza list? Maybe somebody didn't ask for any toppings at all, or maybe they asked for a bunch of toppings that we don't have. And so in those cases, then P, the length of the pizza list, P, would be 0. So if P is 0, what do we want to fill in down here? When we look at the plain and prep portions, well, we want plain at that point to say plain cheese. And notice that there's a space here between your and the name of the variable. So I don't want to add an extra space, so there won't be a space at the beginning of the string, but we do want to add in a space between the variable here, cheese, and pizza. So I've added a space at the end of that string. But on the other hand, prep, we already have the space before the word is. So in that case, we would say prep is an empty string. There's no space at all between these two single quotes. So if P is 0, we're going to put plain cheese in as the value on the left-hand side and nothing as the value in on the right-hand side. So if P is 0, it's going to print out your plain cheese pizza is ready. Then we have other situations, right? What if the length of the pizza list is not 0? So if it's not 0, then we want the plain part to be an empty string because the output that we want is your pizza with whatever toppings is ready. So in that case, we're going to put the single quotes for plain with no space between them. By the way, if you prefer to use double quotes around strings, then this would be double quote, no space, double quote. Okay, So what happens if you have any number of toppings at all? So if pizza has length 1 or greater, then we'll have your nothing for plain, that'll be a blank, your pizza, you want to say with the first topping is ready. So we're putting here with pizza, and then bracket 0 is picking up the first value in there. Now, if P is 1, that's all we wanted to say. We say your pizza with mushrooms is ready, and then that would be done. But what happens if P is greater than or equal to 2? We want to add on to that. We'll add some other things. Maybe if there's just extra toppings, we would add, if there's one extra topping, we would add your pizza with the first topping, and then the last topping is ready. To get all the spacing appropriate, notice I didn't put a space before the and down here when I typed this, so we're going to add in the space. If P is 2, we would say your pizza with the first topping, space, and the second topping is ready. If P is greater than 2, now we have to start paying attention to where the commas and the spaces and so on occur. So this is just one approach that we can take to tackle this. This is kind of stepping it out piece by piece to say, I'm going to construct our way up to the output that I want. What do I want it to look like? Look at it case by case, build our way up to there. If P was 0, if P is 1, if P is 2, if P is greater than 2, all the cases greater than 2 are the same. The 0, 1, and 2 cases have their distinction. So what happens if we have added with pizza and P is greater than 2? So we have pizza topping the first one. So if P is greater than 2, now we want to add a comma and a space to the end of that. And then we want to start adding on the extra toppings with commas and spaces. But we don't want to go all the way to the very last topping, because we're accounting for the very last topping down here with the and. So we're going to start building, and a way to build that is to loop for I in range from 1. We're skipping over the very first topping on the list, the topping 0, because we've already accounted for that one here, the topping at index 0. So we're going to go from 1 up to, but not including the very last item. The very last item we're dealing with separately after the and. And so what we do in this case, we can add on to prep, just add on that pizza topping and then another comma and a space, and keep doing that all the way until we get to the very last topping, at which point we come down here with the and adding on the pizza. Now, this is because we're accounting for the Oxford comma. If we weren't accounting for the Oxford comma, we have to deal with that slightly differently. Different approaches that we might think about. Okay, but what will this do? This will then account for 0 topping pizzas, so just a plain cheese pizza. A 1 topping pizza will print out correctly. A 2 topping pizza will print out correctly. And then 3 or more toppings will print out correctly. And I've done it in this way so that we can see kind of our step-by-step approach to building up to that. Then what do we want to do? We now want to check our work. So we want to check the output, make sure that it works in all the possible scenarios. And so one possible scenario is we could say, well, what if the requested toppings that we requested in our particular setup was just an empty string, or in this corresponding scenario, if pizza were an empty string, empty list, excuse me. And we check to see what will happen. And in this case, we should get your plain cheese pizza is ready. If we just requested one topping that is available, then should say your pizza with mushrooms is ready. This particular example, we have a couple of the toppings that were available and one that's not. So this one should say adding mushrooms to the pizza, adding black olives to your pizza, French fries are not available, and then print out your pizza with mushrooms and black olives is ready. And then we keep going, right? This one will have 3 of the available toppings and a couple that are not available. This one has all 4 available toppings and a couple that are not available. And so it will print out correctly in all the cases. Now, if something were to be wrong in our code, we would see a wrong spacing or wrong use of commas or something like that. And then we can go back and edit that approach. We made a mistake somewhere. We caught it in our looking back, and we can figure out what's going on. Now, for the looking around portion, there's a couple of things we can do in the looking around. So we could look for different solutions to the problem using a different thought process, a different direct approach, or using more powerful tools like the join method that's available in Python and some other things. But we can also, if we're happy with this solution, we can look around for other places, other ways to apply this in other scenarios. So when we come up with a new problem, we're like, oh, I need to be able to do this thing. Oh, that reminds me, that's like that pizza problem that we did. I can use that same technique in this setting. So we've gone through the kind of the 4 steps, thinking about what the problem says. In this case, pretty straightforward. But then the going through the pseudocode, kind of saying it in mostly English, converting that into code, and in this case, it was almost directly a direct translation. In some situations, as we go forward, the translation will be less direct. But we have this direct translation, had to kind of think about piece by piece, how do we achieve the task that we want to achieve? What do we have to do? How do we get from where we are to where we want to be at the end of it? And then on this slide, looking back, checking our work, coming up with enough test cases that will cover all of the scenarios that are important. All right, so as usual, feel free to ask questions in the comment section by email or on Discord.